Okay, let's see if I can make any more progress today. It's the next day since I paused the video. So we there was something that I was confused about, and that was over here. We have these katakana and hiragana, and they're kind of like explicitly given, and we don't use automatic conversion from hiragana to katakana, which is what this last bit is for. This means automatically convert the hiragana to katakana. So I'm going to figure out why. I think it might have something to do with these being two code points, a composition of one and a second code point. So let me see if I can figure this out. Okay, so it's only one code point. Um, So let's do this. We're gonna search for some information. Hiragana. Um, we're gonna look at the range of Unicode code points that represent the hiragana and see if maybe this doesn't fall in that range. Maybe that's why it looks kind of funny. Let's see. Opening up browser. So we'll do this. Okay. And let's see. Oh, that's katakana. So let's look for this one. No. Oh, so probably what's wrong is that this is the one that's composed and the katakana is one that it's not. So if we do or hex. Okay, right. So this is going to be complex to support in our like what's it called, like in our kind of stats program, because these are basically not these don't really conform to the automatic conversion between hiragana and katakana. So I wonder how I want to handle that. uh, let's see. So we could just remove support for these during the kind of stats gathering. I'm sure there's going to be 0 of them anyway. And I guess that's what I'll do. Um, I'm I'm kind of okay with that. Uh, so the thing is, this also is not going to be supported in the automatic conversion from hiragana to katakana. So so we're at least going to have to check for this, because basically when we're doing the stats, I'm going to have two columns, one for hiragana and one for katakana, and it's going to say, and one for like total. And so it's going to say like how much of each version of that syllable appears, and this one's going to be an exception. Now those six characters that I highlighted over here, these are also exceptions, but different kinds. And I think that rather than code the exception logic, I'll just exclude them completely. Um, so yeah, we maybe we should finish this function that we were just writing and collect potential mappings. Um, okay, so we want to basically expose this function for other uses. Um, and what I'll do um, is I will commit the kana stats change into this. I'll amend it rather. So we'll do this kana stats.c. All right. And then we're starting a new commit which handles the hiragana to katakana explosion. So we'll have to add a new test case because basically this function already works, um, but we do want to add some tests to it because I'm going to be using it in a different context soon. So well, I'm not sure what my present directory is. Okay, I'm in the wrong directory. Source. Okay. No. Okay. So let's open Romaji test. Right. Start test. File. Hiragana. Kana. Okay. Now I think this just takes one argument. So uh, let's see here. How do I want to do this? I guess I'll have like a some kind of a test case list. So we'll do something like struct const garbage and converted. Okay. Let's change this to conv, because we're not going to be changing anything that's greater than a convert that's longer than a conversion string in our input system. So we'll do test cases equals. So let's test this. So if empty string should work fine, and let's make sure that we can compile what we're doing. Get Romaji codes, too many arguments, kind of stats. Okay, so this has to be updated. How did my working directory change again? Let me change the tmux window title. That's confusing. New source. Okay. Now, let's fix that compiler error. Get Romaji codes, Romaji config. Okay. Conv is not known. I think that's conv is declared in romaji.h. Yes. So we'll do test cases unused. All right. So I think this is going to work now. We'll also have an int test index for test index 0, test index less than size of test cases divided by size of test cases. Let's just call it I. Okay, good. And then, so do conv scratch equals test cases I dot orig. I think that kind of assignment works. Int scratch. Okay, no, it doesn't work. So we'll do memcopy scratch gets this. Okay. Good. So then we'll do hiragana to katakana. And give it scratch. And if compare scratch and test cases I dot converted. let's give these more distinct names. We'll call it input and output. Input, output, okay. Input. To failed. Okay. So I guess the way our test system works is that we exit as soon as there's a failure. Isn't that correct? Test util.c and test. Yeah, we have these die calls in case the test fails. So let's do this. Intf. Expect input, and then expected, then actual. And we'll give it test cases I.input, test cases I.output, and actual is scratch. Okay. Failed equals 1. And we say if failed. Oh, so what we can do is we can actually print out the error. xfprintf out, right? Or error. And then we compare that string to empty and test. We need it to be empty. That means there's no errors. So we don't need this. Variables. Okay, try that. All right, the test apparently passed. Now if we add an A here, that should not work. Right. Okay. So let's add some other test cases. Do this. And do we want to I think we want to handle. Oh, we don't need to handle katakana. My plan is that we are going to. The caller is going to check to see if it is katakana before it invokes the function. So we'll just want to handle normal, very, very simple stuff where everything is kind of expected and normal. So we have, let's try this. Let's try something more different. Okay. And let's try one more with 3 characters, just because we don't want to. Okay. Maybe we should align these. Okay. That makes them easier to read. And let's try this again. Too long. Oh, that doesn't work. Conv cannot be that long. That's interesting. Okay. Let's do that then. Let's also try something kind of different. So we have like this. These are somewhat more unusual characters at the very end of the range of hiragana and katakana. So it's probably good to check these. Then, okay. Good. This just barely fits on one line. Scratch. Okay, we don't need the curly braces, I guess. And yeah, let's try that should work. Okay, and so we're going to say this is where we expose, this is a commit where we expose the hiragana to katakana function. Call this make hira to kata function public. All right. So now we're going to need a function which checks the checks if something is in the range of katakana or hiragana or neither. Because what we're going to do is when we print those two columns, we're going to have to we're going to have to loop through the hash map that has the counts of each different character sequence. And in the hash map, katakana and hiragana will be separate. But when we're looping through to show the stats, we do need to kind of say, hey, if this is katakana, then let's just ignore it. Or let's just not print it out now, but print it out when we go to the hiragana, when we hit that in the iteration. And when we hit the hiragana version, then we're going to convert it to katakana and then print out both at the same time. Okay, so yes, so that means we're going to go to romaji dot. Or but wait, we do need that, don't we? Yes. Okay, romaji dot each. So we'll say something like int range or code point range do char const c undefine code point range hiragana. Let's call this one katakana. Oops, caps lock was left on. And then call it other. Let's start with 0, actually. Okay. Katakana other. All right, so let's open romaji.c. What does our commit look like so far? Okay, good. Then we'll do a hiragana to katakana here. But do we need to do it this way? Perhaps we don't actually want to put it as public in romaji.h. We actually want to put it in kana stats. Yeah, I think that is how I want to do it actually. So we don't really need it here because we can just put it in kana stats. Let's see. And say something like is hiragana, I guess. Do we want to check for other stuff? Yeah, let's say is hiragana. Now let's do the range because it really depends on how we want to handle this thing, which is not really hiragana or katakana. Actually, let me confirm that. Let's see here. Let me see what that dash is because there's no like equivalent. So there's no like equivalent hiragana for that. It's just like a single character without a conversion. Here. Okay. Okay, so it's here. Choon kigo. And then what does it look like in the hiragana version for that? So this is f minus 1, 2, 3. 3 from the end. Oh, and then we have, okay, so this is actually after this is the last one that has a hiragana equivalent, and so these are all purely katakana right here. And I don't think I actually have this. Do I have this in the? Do I have that in the table? Romaji. No, that's kind of bad. Maybe I didn't put it there because it was not, it wouldn't be useful for all except a very small like set of text. But for some reason I thought these would be useful. But anyway, okay. So it depends on how you want to handle this character here. So if we only have this character, it depends on how many characters that do not qualify as either hiragana or katakana. And this is one that appears in only katakana, so it's kind of special. So we have to have a separate piece of logic for that one. Um, so we the thing is, if there's only one such special character, then we don't need the code point range. We need like a boolean that returns hiragana or other. And then we have a separate check to see if it's equal to this. But the thing is, we might add more characters besides this one. So I'm that are special or unique, and because of that, I think I'll just use a range function to be more future proof. That means that when we change the code later, it won't have to change so much. So we have a code point range. So if stir cmp. Okay, so the first thing is okay, so it looks like we have what are the ranges? The contiguous ranges. So there's katakana which starts at 30A0 and hiragana which I don't know. All right, this is first. So what we'll do is we'll check to see if it's lower than this first, and then if it is, we return other. And I forgot to copy this. Okay. Point range. If stir cmp c, what was the first character? Okay. It's less than 0. Then we can return code point range other. Okay, if stir cmp c is below this 3096. 096. This is small k, so we have 0. Then we return code point range hiragana. Let's just keep the blank lines at a minimum. So we have if stir cmp c is next. We want to see if it's below less than this double hyphen. We don't have to worry about if it's okay. All right. Oops. 0 is less than 0. Then it's also other. Paired. Let's say here, because I want to explicitly state that there are some hiragana and katakana that don't have equivalents in the other set, and those will just count as other. Hiragana, kana, katakana ranges only include those characters with a corresponding alternate in the other kana type, kana region. All right, and we can probably confirm that this range is the same, or this has the same amount of space. So let's finish this. Actually, let's just finish what we're doing. Okay. Less than equals 0, then return code point range. Kata kana. Right. Otherwise, return code point range other. Okay, I think that's the least number of comparisons that we can do and still get the correct answer. So what I'll do here is I'm gonna do some math here. We'll do. Oh no, I don't want to do math with the character. I want to do math with the number. So we'll do Perl dash e say minus 1 plus 1. Okay. 86. And then if we do the same thing for hiragana, we'll probably see the same value. 96 and 041. Yeah, so there are 86 characters in each range. Okay. And so we are comparing, in this example, we are comparing we're comparing UTF-8 bytes rather than Unicode Unicode code points like the raw values that I typed in here. And that is okay because UTF-8 works such that the most significant bits are stored first. And if there are and the greater number of 1 bits at the start indicate a greater length of bytes after it. And so it means that we could just, it's okay to just compare without really thinking about what length the length is. Now we could like explicitly say if the length of this code, of these UTF-8 bytes is greater than the other one, then we know the first one is larger, kind of like we're comparing actual numbers. But we don't have to do that. We can just compare the bytes one by one without even caring about the length. It's almost as if in decimal numbers, like imagine you had like 1, 2, 3, 4, and to indicate that it was 4 digits long, you put 4 nines at the start. And then this other number is like 41, and to indicate there are 2 digits, you put 99 at the front. Let's just put a 0 here. That actually more matches the reality. And so to compare 1234 with 41, you could compare them as actual numbers, like this is a number, a real number. I mean, a normal integer, rather. And this is a normal integer. You could just compare them as integers, like including the nines. Or you can kind of compare them like lexicographically, like a dictionary. And so in that case, you would see these two are the same, so they cancel out. And then you see this one is larger than 0, so this one comes first. And so the idea is that, yeah, you can do either one and still get the correct comparison result with UTF-8. So, good. Now, let's make this, we want to put this in the kana stats command. So we're going to do x up equals h2 kana stats. Okay, get rebase I. And this kind of stats need to go last, I guess, doesn't it? Because so what I'm about to do is I'm going to add support for so applying make it kind of stats. Okay. Okay, let's save this. Apparently we didn't do a good job of keeping. So we're going to do /temp/ks.c. Must have made a mistake somewhere. So we're going to do git remove kana stats.c, because this comes before kana stats. Make hiragana to katakana function public. Then we'll do gc git rebase continue. Then kana stats command. Okay, good. it's still there. So if we do diff kana stats with temp kana stats, that one's not correct. Okay. So make code point range. Okay. All right. Okay, so what I'm going to do next is I'm going to allow this stuff to not actually be excluded from the from the set because we don't really want to try and manage these since they don't convert cleanly between katakana and hiragana. So let's open nomaji.h, and perhaps we can take this opportunity to fix the other problem, which was that that we didn't have that wa with the dakteng attached to it. I'm not sure why it's not there. Let's see, where does it go? Right here. So we don't have that for some reason, and that does exist. That does not exist here, right? So vu hiragana letter vu, so hiragana vu. Okay. So what we'll do is we will add we'll add something like unsigned include include fa. Now this include kana wa or include kana va. There. Whether to include spa. So yeah, and what keys do we want to assign to it? Because I'm not quite sure how that's going to work. So we go, let's see, do we have VA assigned to anything? We have VA assigned to that. Okay. Now I guess for consistency we can have it be this XX thing. XX something, XXD, K and L, and C, and otherwise XX. Oh, but we could just have like va be special, right? So that va only occurs in katakana. We do that for a lot of stuff. Yeah, how do we want to handle this? So what I'll do is I will say, so I'll put va in this category because it's very similar in that it only has a katakana code point. So it will be here, and it will be able to exclude. So let's add that last. Let's delete this. Edit temp / comment. All right. Okay. So we're going to say whether to include katakana hiragana for let's see, call it wa gyo with dakteng. See, where did that go? Dakteng. Okay. Unsigned. Call it. Oh, but I guess we want to make that separate. We still want the existing test to work though, don't we? XX. Yeah, so maybe we have to do a separate commit which only which only actually adds that character, and then fix all the tests, because I don't think I can justify having this as a flag, um, having it a flag that only specifies this character. That's kind of funny. Um, hmm. Yeah, I'm not sure how I want to handle it. XX, let's see, what do we have here? Do we have XXA? That would make sense. Nope, don't. We already have that. XXB. We don't have an XXB. What about XXW? We do have XXW. Um, XXV. We do have XXV. XX. As you can tell, I'm trying to assign a unique XX something input. Okay, XXB is not available, but that's kind of hard to type. What about XXF? XXF is available, so let's just do that one. TKL. I'm wondering what was my logic between choosing this order, XXD, XX, J. Because wow, this is going to have to be first, isn't it? Wow. XX. I guess it could be first because there's XXC there. Okay. So we'll have okay. XB. Let's have as is. This first one means as is, and next one means whether or not to automatically convert. And we can't automatically convert it. So let's just add this, even though it's wrong. XXB, B. Okay, XX, B and B. So let's change this. This is going to be wa with a combining thing there. So we want to let's take this and copy and paste it here. And here. No, it's not letting me kind of take it. So let's do. I think there's a way you can like get the first bytes of something. Head dash B 3 or tail. Let's do man head first. Man head. C, print the first num bytes of each file. Okay. But I guess we want tail of this, don't we? C, up at the last num bytes, or C to up at starting with byte num. Okay. So dash C 3. Tail dash C 3. That. We want that character. So we're going to take the doctang off of this and put it on something else. Oops. Okay. That's 3 bytes. Okay, good. So what I'll do printf of wa and then tail dash. Oh, that didn't work. That's funny. Why did it not work? Okay, so that's strange. Why would it not be able to combine these two characters? This might be why I didn't include it. So maybe I was smart to not include this earlier, because it's acting kind of weird now. Printf wa. So let's see, how many bytes is that? Let's see. Only 3 bytes. Okay, something is weird. Something is not correct here. All right, that's why. Okay. I do not get that. Why is it not combining it properly? Hiragana letter va. Let's do hiragana letter va. This foreign language words. Because it was used for foreign language words into transcribing foreign language into Japanese. That's why I didn't include it, I guess. Used for the kata. Oh, but this is about katakana in general. Um, names really kind of used to represent non-native sound va, as such is only found in borrowed words. Maybe pronounce this more like ba. Va, see more use. Okay. Okay. So in that case, I suppose what we want to do is, let's see, we have let's just not solve this problem right now because I don't really know how to do it cleanly. It just at the moment. So what I'll do is we'll have this here. Do whether to include. Okay, so I'll actually do this. Agyo with duct. Okay. All right, and by default that should be on. So we'll do nomaji.c. Oops. Okay, let's go. XP. Okay, let's remove that, I guess, because there's not much we can do about it. I did kind of think that maybe we could just replace this with this, like what it was suggesting. Here, this. That is pretty close, I guess. But va is not actually used, right? So here, yeah, let's do this. Let's include va, do that, and you include it as don't automatically. Okay. So so yeah, after all, even though I'm kind of going back and forth on this, but we'll say we do kind of need to handle this, whether to include let's copy as signed include katakana. Okay. And so then we're going to go ahead and open up, see. Okay. Set the default, romaji.c. Default romaji to config dash include katakana va is true. And so now we're going to see a bunch of tests fail. Or no, we actually have to read this before we see any tests fail. So we don't need to. If config dash include katakana va, then we'll just say append mapping. All right. Code point range. Okay, we never handled that thing. So, kana stats. Let's open this. Okay. Okay, lots of failures. So the question is now, do we want to change this? I guess I don't really want to fix a test so that they they um they pass with different output. I think I just want to change the flags in the test so that they behave properly, or so that they stop failing but still behave the same way. So let's open up Frodomaji test default. Where's init? Free kanji. Here we go. Free kanji keys.c. Oh, but we don't have any parse. Okay, parse romaji flags. So we'll go to okay. Let's go to romaji.c and parse g flags. By the way, let's save that change to kana stats. Yes, then we want to go this if cmp argv0 include no katakana va. Okay. Then we'll say config dash include katakana va equals 0. And then we will increment all this stuff. All right. Edit romaji test. Okay. Romaji test. So for this romaji test, maybe we can, I don't know, maybe we can change the flags or change the expected test case. Yeah, I don't know. Here, let's say no katakana va. Right. I guess I just don't feel like changing it. All this stuff. Okay, it's failure. Oh, there's only actually one test that has to be updated, or two rather. Let's try that to make romaji test. Args. Okay. Test out. Free kanji keys, no kanji numerals. Oh, where is that? No. There we go. Romaji test. Okay, and then we're probably going to have to add that mapping test. Let's add a mapping test, I guess. So I don't think I want to add this. I want to add the test for the katakana va somewhere, but I'm not sure where. There should be a test where we just generate the map. Edit kanji mapping. There was something like mapping something or other. Mapping. Make map test. That's what it was. Okay. Let's fix the other test now. We have input test first key k. Test first key k. Let's see here. Okay. Okay, so what's different here? They look the same to me. Oh no, we're adding something here. Something's changing over here. So we no longer have a single key kanji character somehow. Let's open that up. So this character is no longer able to be typed alone, I guess, as just a single key. So that is here. Okay, V is no longer possible, but That doesn't make any sense. Why would it not be possible? We only have capital V taking up a code point. Oh, shift. Oh, right, right. It is capital V, so it is shift. Okay. Yeah. Honestly, I think that character is very rare, and I don't want it to take up such um, a prominent position in the keyboard. So, okay, how am we gonna handle that? We got to find a better key code for it, I think. Yeah, so that's why I didn't. So probably my first instinct to make it XX something was correct. So let's call this include va, and we'll put it as XXB or whatever. XXB. In that case, we can have it off by default, I suppose. Actually, no. We'll just keep it on. I get lost in these details sometimes. I should probably just stick with one decision. So let's put it here, XXB. Okay, where did my va go? Va here. Okay. Right. Oh, but we don't want to put it. We don't want to put it in this table, do we? So include va xb. Okay. Like that. XX. But that's kind of hard to type. XXJ. Do we have XXJ? Okay, let's do XXJ. All right. Include va. Okay, so let's add that field. Include va. Include va. We'll include that and XJ. Okay, include va. Now we have to set the default. Edit romaji.c default. Kana va will be 0. Let's just make it keep it like that as it is. And then we want to do parse romaji flags, and we'll say include va. Okay. Right. So now I think we want to undo the changes to romaji test. Yeah. We'll say make map tests is where we'll change some stuff. Start test. No kanji, and include va. No kanji. All right. Okay, good. Oh wait, why did that pass? That should not pass. I didn't actually put the end test here. Okay. Then let's see. J. Why is it not XX? include va. Why? Oh, because I set it to 0 in the parsing logic. To 0. We want to set it to 1. Okay. Good. All right, we're getting there. J, J. Still not in the file for some reason. XX. Still not there. What happened? Edit, make map test. Include va. No kanji include va. Make map. So make map. We parse it omaji flags. See. What is going on? Code. Oh, because we are returning early, aren't we? Edit romaji dot. See here. Edit. Yeah. I bet we're returning early. No, we're not returning early. Config. Oh, did I not update the test? Right, I didn't update the test file. That's funny. Okay. So XXJ, XXJ. Okay, good. Finally. So now we will do add romaji flag for including and what was that other one? Okay. Okay, good. All right, now we can do the flag for those other ones. The include these ones here. These ones that are exceptional and don't have hiragana equivalents right here. We're going to add a flag to add or remove these. No, not those. These 6. Okay. We'll do this. If config dash include or about wagyo with dakuten. Okay. Right. And mapping. Okay. Oopsie. Right. Oops. I want S. There we go. Good. So now we're going to add that back to the romaji struct. All right. And the default will be on. Edit default. Do config dash wagyo with dakuten is on. All right, now that should all just pass without any. As soon as I get to compile, of course. 564. Okay, good. So now we want to go to the parse function. Oops. Do if not stressing p argv0. No wagyu with ducting dash wagyu with ducting is 1 0. All right. Good. Good. Okay. Now we need to add another map test. No kanji, no wagyu with ducting. No kanji, no wagyu with ducting. Okay. All right, let's see if that worked. So what do those codes look like when they have them? Oh, maybe we should compare it with no kanji, this no kanji one. Let's compare those two. Diff expect to test out and make map test dot no kanji and expect to test out slash. Okay, that looks correct. Okay. Okay, fine. That looks like a good commit to me. So we'll just add this and say add no wagyu with doc10 flag. These are not included when collecting kana stats. Okay. Okay, so let's move this commit to the head again so we can start working on it. Oh wait, was there one other thing we wanted to add? Was there another flag? I don't think so. Romaji.c. And xxj. Include va. So include va is off by default, isn't it? Edit romaji.c. Include va is off. Just want to make sure I'm aware of what's going on. I don't want to lose myself in the franticness that I'm coding in. So include va. Yeah, okay. Oh, we want to look at parse flags. Include va is off by default. Okay. Okay, so I think that we can now move some stuff around here. Kana statistics. Oh no. Kana stats command. Oh, what is this? Kana statistics. Oh, right. That was a spreadsheet that I checked in a while ago. That's not related to this commit right here. And this conv. Oh, does that conv? Is that needed elsewhere? I think we need that in a previous commit. So if we do make, that should pass. But if we check out to, this probably will not pass because we don't have conv. Yeah, that's a problem. Okay, so let's do C1. Okay. So let's do let's fix that. So we're going to start a new branch, and we have to add this where checkout. Where did the problem first appear? I guess it first appeared here, right? So if we do H4, we'll see that the problem still is there, right? But if we do H5, then the problem is no longer there. Okay, so H4. So we want to add this to romaji.h. Okay, let's go to romaji.h, and okay, let's paste this here, orig. Oh, what happened here? Key mapping. Type def char conv 7. Okay, good. So this is a fix up of H4. Fix H4. Okay, and then we're going to go to kana stats and rebase onto fix conv. Okay, and we'll probably see that this kana stats no longer changes romaji.h. All right, now we're going to delete fix conv and git rebase. And okay, good. So we've almost kind of gotten everything out of the way to implement this. I think that we've basically gotten everything out of the way. But I think that yeah, now I mean those flags that we added for Romaji were a pain, and I knew that it had to be done, and so I wasn't able to think about the actual algorithm very much for this. I actually know more or less what I'm going to write, but not in great detail. Essentially, we're going to be pulling bytes into an array, and then that we look for that array in the hash map of like Romaji to counts, and if we find a match, then we increment the count. If not, we keep reading bytes. And there's also times when we have to basically reset that byte array because we don't see any kind of potential for a match. And in that case, we just drop the first byte and ignore it, and then we put the bytes in the array back onto the stream, and then attempt to read that way. Let's start reading again as if nothing, as if we're reading them for the first time, reading the bytes for the first time, and then we go on looking for matches between the bytes there and the bytes in the stream and the bytes in the hash map keys. Um, so yeah, I think I'll stop the video for now, and then after I've had a while to think about it, I'll be ready to write this, get down and start writing this code. So thank you for watching.